Gang, let's move on to the very last mystery impairment. This is a fun one. And it is a quasi square wave. And this came from Mike Odell, who was actually the star of a couple of those videos from Comcast that you saw. Folks, I love this one because this is not in any of our documentation. Mike brought it up and said, hey, what is this? And I had a couple of an idea and it was not correct. So I'd like to get your takes on this impairment. And then we'll go out in this field, watch the video. And just for everybody watching, nobody's seen this video except for myself. So it'll be interesting to see what our conjecture is.
Did somebody shove a square filter into a round coax?
That's funny. No, not it at all.
When I saw this impairment, of course, we haven't seen the video yet, but when I saw this impairment in the full band capture, the first thing that came to mind was, well, maybe there's a CPE issue. And then the second thing that came to mind was a power supply issue in a drop amplifier, or maybe for the cable modem. And what we could be seeing is the impact of amplitude modulation across the RF spectrum by we'll call it a kind of a square wave as a result of a regulator not working in say a switch mode power supply or something. Beyond that, I don't know because I've not seen this before.
I had similar thoughts too.
Great guess, Ron.
Something active. It looks like an active influence.
Yep. And what else? Brady, take a stab at this one.
I've actually seen this before. And I've seen it working when I worked for other test equipment companies. So I believe I've seen this before. I believe this is the ALC fluctuating up and down, and you see it on a swept spectrum analyzer. If you slow down a sweep time, you'll actually see this stair step casing. You can see it better or worse. But there's something I believe is causing the ALC on the amplifier to go up and down. And so what's happening is the power level on the amplifier is going up and down. And so as the spectrum analyzer is sweeping through, you see it. And I think probably what's happening here on the, this is not a true ADC on a full band capture modem. You actually are getting like bins, you're getting sample sizes. So it kind of acts like a swept spectrum analyzer when you capture it. So you're actually capturing those power variations when in the full band capture modem as you're going through.
Interesting.
That's a solid guess. So let me tell you where I have seen something similar. Then we'll watch a video and we'll all exchange notes about who was right and or rightest. So I have seen some field meters, for example, they have multiple tuners, and the tuners will sample and then interleave them, and they use the two tuners and interleave the measurements to increase the speed. You can, if you can manipulate two tuners at the same time, you can go twice as fast. And then occasionally the front end of one of the tuners will become damaged. Most Comcast techs in the early days have seen examples of this. You'll have an amplitude variation from tuner 1 versus tuner 2, and when you stitch them, you result in something like this. Not it. This was coming from a node, and there was multiple customers on the node with different types of equipment seeing the signature. But that was the only guess that I had completely not correct. With that, on to the video.
Okay, the mystery makes sense now. So in the full band capture responses of all the devices that are past this line extender, this is a 1 gig Aris 331 line extender, we had this really weird periodic kind of quasi square wave on the downstream, and it didn't really make sense. But now that I'm up here and connected to this amplifier, I think during the period of time that we were capturing that traces, you can see that the output response of this amplifier is just bouncing across the entirety of this spectrum. So now that quasi square wave actually makes sense. So let's crack this amp open and see what's causing this. Okay, so now that I got this amplifier open, as soon as I opened the housing, that output variability stopped. So the levels stabilized and that variation stopped. So here's my amplifier. This is a pretty new build. Like I said, this is an Aris FM331 line extender, so this is a pretty new amp. But yeah, for whatever reason, when I first hooked up to that tap, those output levels were bouncing up and down. And I think what was happening, looking at the spectrum capture, was that the FFT bin captures were periodically capturing the devices off of this amplifier in their high and low states. And that's why it looked like that square wave response. So pretty fascinating one I've never seen before, but this amp's off a little bit. We're gonna go ahead and set it up and close it up and make sure that everything's tight and properly adjusted. And then we'll see what happens after that. Okay, well, we've got the amplifier closed back up, balanced, set up in both directions, gave it the old wiggle test, and we're right back on that tap where we started, and not seeing the fluctuations like we saw before. So it was an AGC, and so potentially the AGC was bouncing. We turned it off and left it in manual, and it seems like it's stabilized for now. So we're going to keep an eye on this one to see if we see that trace and see that response start bouncing, we'll know exactly where to come back to.
And Brady gets the win. The W goes to Brady for calling it the ALC. Well played, well played, folks. We have just 4 minutes left. Let's quick chat about this square wave signature. And then there's a couple of great questions and points made in the Slido I'd like to quickly run through if we have a minute or two to spare.
But definitely a tricky one. That's one I wouldn't have guessed.
Yeah. And it wasn't a Super Ball inside the amp case.
Yeah, so I think it does tell you that when you try to interpret things like full band capture, there are some things about it that it's not exactly like a full analog to digital converter capture across the whole spectrum. So it can leave some things out, things like the noise floor, and I know we've talked about that. That'll, I think, be coming out in the Working Group 7 panel. Our paper. So there is some things that can kind of distort what you're looking at sometimes, and you have to really look more deeply into the data that you're being presented with.
I'll just add, some of these are very accurate in terms of what it is and where it is. Some of these are less so.
Well, the point of this document, folks, is a lot of them are incredibly accurate. You can look at the first 4 or 5 of these and hit it 99% of the time after you get trained at interpreting these things. And the concept of this paper is that we can transfer that knowledge to the field as quick as possible to have the most consistent repairs. So we, if you can spend a couple extra minutes reseating that module and hitting all the screws rather than just kicking it or whacking it with a stick to make it temporarily go away, we'll all be in much, much better place. So that's it. We got a couple of questions from the field. I'm going to read these off. If I can find it. And I cannot. Oh, here it is. Sorry. This comes from Jonas Lynn. Thanks, Jonas. The first one in channel alignment power issues. There's another scenario that isn't head-end related, which is totally true, and we actually call this out in the document. Is that there, in the rare case, there is a local channel insertion for certain MDUs and bulk properties where they'll introduce a brick wall filter and combine a local QAM thing for things like closed circuit television and local programming. So again, very good point. It's not fair to say always head-end. But it's always combining related. Folks, any comments on that?
That's a great point. And as you note, Larry, the operational practice that SCTE's Working Group 7 is putting the ribbons on does cover that.
Yep. Oh, we are at time. 1 minute left. Most important, special thanks to Arnie Lundell from Cogeco, David Kelly, Mike Odell, and Kevin, Doug, Mark, John, Andrew, all Comcast, all these guys working hard every day out in the field to fix these problems. We really appreciate you taking the time to work with us on these videos. Congratulations again on PNM. With that, folks, we're at time. We're going to wrap it up, and thanks for joining. We'll see you next year at PNM Live.
Keep on PNMing. Thanks all.